Okay, we're gonna start lesson 8. This is lesson 8.2, which is rotations. So you should have a foldable that looks like this. We're gonna go ahead and fold it. You can glue it there if you want, but just for the sake of the video, I'm not gonna do that. Okay, and you can cut these flaps here in glue so that it's a nice little foldable that you can have to review rotations. So we have 90 degrees counterclockwise, 180 degrees. Either way we go on a clock, it's going to end at that same 180 degrees. So if I thought about this like a clock, ignore my really terrible circle. Okay, I know I have 12 at the top, and then 3, and then 6, and then 9. Okay, so I'm going to use that kind of as a guide here. Let me zoom in a little bit. So 90 degrees counterclockwise. First of all, counterclockwise would be the opposite way of a clock, so it would be going to the right. So counterclockwise, going to the right there, would be the same thing as a certain degree clockwise. So we can go either way there. 90 degrees would be a fourth of a turn. So like going from 12 to 9 would be 90 degrees counterclockwise. If we were trying to start at 12 and get to 9 and go clockwise, we would go all the way 3/4 of the way, 90, 180, 270. So this is the same thing as 270 degrees clockwise. Okay, so that's 90 degrees counterclockwise. Same thing as 270 clockwise. So again, this is a fourth of a turn, just like we would go from 12 to 9. So let's talk about 270 counterclockwise. So starting at 12, if I went counterclockwise, 270 degrees, remember it's 90, 180, 270. We would go all the way around to get to that 3. Okay, so again, counterclockwise is against the clock. But if we decided to go clockwise, then we would be going from 12 to 3, 90 degrees clockwise. Okay, so that's the same thing as 270 counterclockwise. So we want to consider that as we're going through these. I wrote clockwise out in words here, and I wrote it abbreviated here so you can tell the difference. Clockwise, again, would be going with the hands of a clock. So you can always you can always remember that by just looking at a clock. The direction at which it's going would be clockwise. Okay, so either way, 180 degrees, either way I go, either counterclockwise or clockwise, is going to take us to the same place from the 12 to the 6, either way. So 180 degrees, either way we go, is the same location. Okay, so that's kind of what we're talking about there. So let's go ahead and start with 90 degrees counterclockwise. Okay, so there's different ways we can do these, and I'm actually going to show you all 4 methods, and the 5th method isn't really a method, it's just kind of a visual way to do it, the way I sometimes do. So if you're more visual, sometimes this will be a little bit easier for you. Okay, so the first one, we're going to go ahead and use a method called using patty paper. And we're actually using hamburger patty paper as tracing paper. So this is our first method. Patty paper. Okay, there are rules that go along with each of these. We'll do the rule on 180 degrees, but no, you can always use the rule here, but they aren't given to us on the EOC, so that's why I teach a few different methods. Alright, so our first step here, we want to go ahead and graph our pre-image. This is the same thing that we would do if we were doing a translation or reflection. So we have our three pre-image points here, A, B, and C, so let's go ahead and graph those, starting at the origin. And C is 7, 2. Okay, I'm gonna, oops, sorry, getting used to this new dot cam. I'm gonna use a ruler to go ahead and make some straight lines here, straight edges. And this is my pre-image. Again, pre-image means before the transformation has occurred, so before we rotate it. Okay, we're moving at 90 degrees counterclockwise. The first step, again, with all of these rotations is going to be taking a step back and saying what direction am I moving. Here, counterclockwise means I'm going to the left, and how many degrees, so how many fourths of a turn, so just 1/4 of a turn here, and you want to think about where you're ending up so that you have a visual idea of where you should end up. So I like to go ahead and label my quadrants. We label them 1, 2, 3, 4, like the shape of a C going counterclockwise. Okay, so if we're moving 90 degrees counterclockwise, that means we're going 1/4 of a turn, so we're just moving one quadrant to the left, so we should end up in quadrant 2, and that would be 90 degrees counterclockwise. If we end up somewhere else, we know we've made a mistake, so it's always good to kind of think where we're headed before we start, and that's a good little life nugget thrown in there for you. Okay. So our first method is using patty paper. So you would take your patty paper, which is my tracing paper. I can see straight through it. And I want to kind of make some landmarks here to make it easier to rotate. So it doesn't matter where on the patty paper you do this, but I'm going to go plot my origin. That's the point that I'm going to rotate around. That is my point of rotation, where I'm going to put my pencil or pen, and then I want to go ahead and draw my X and Y axis, so I have a little bit of a landmark. And then I just do this for myself, not really necessary, but I draw an arrow there so I can tell when I've reached my 90 degree rotation. Okay, and then I want to very carefully label my points, A, B, and C. You want to get them as close as you can to the actual point of intersection there, or vertex, I guess, right on that grid, so it's more accurate. Okay, and again, we're rotating to the left. I'm going to put my pen or pencil on the center there, and then we are literally just going to rotate until that arrow has turned 90 degrees counterclockwise, which would be turning to the left. Okay, and that is my 90 degrees. Okay, some people at this point peel up their paper and copy it down, but sometimes it's a little tricky to be accurate there. So I'm going to go ahead and label my A prime, B prime, and C prime points just straight on the patty paper here. So A is at, A prime would be -1, 2. C prime would be -2, 7. And B prime would be -8, +3. Oops, -8. +3. Okay, now that I have all of my points, I can just slide those off and then go ahead and copy my new points on. And since this is my image, I'm going to do it in a different color. Okay, so there are my 3 points. I noticed when I put them on my patty paper, I switched B prime and C prime, so I just corrected that. So there are my 3 points of my image, and that is after it's been rotated 90 degrees counterclockwise. So my jobs here is done, but we can kind of take a look and see what our rule actually is by looking at my pre-image point A and then my image point A prime. And then go ahead and make a general rule. So it would move from xy, so 2, -1 became -1, 2. So we see that my x and y has switched places. So it is y, comma, x now. You can write that there. And then we want to notice which one changed sign. So the 1 changed from a positive to a negative, but in my pre-image, that was my y. Okay, so the y has actually been negated there. So xy changes to -yx. So again, you can always use the rule for these. I'm just showing you one method. This isn't probably the most ideal method because we don't get to use this nice patty paper on an EOC, but it's really good to start learning how to do it just so you can visualize that actual motion. Okay, so our next method, we're just going to use the rule here, which some people really like, but again, the reason I don't love the rules, these are for all my rule breakers out there, is because again, you can't use, they're not given to you on the EOC. Sorry, lost my thought there for a second. You can't use the rules on the EOC because they're not given to you. So this is another one that you have to memorize. And I think we have enough to memorize already on the EOC, so I don't want to add anything else to it. That's why I don't love these, but actually for the 180-degree rule, it's very simple to remember. You just negate your x value and your y value. So nothing switches around. It's not like one or the other. It's both changing the sign. Okay, so let's go ahead and plot our pre-image point here. I'm going to pause while you do that. Okay, so I've graphed my pre-image here. Again, if you need some review of graphing, make sure you go watch a video on that or come ask me in person, but you should at this point be okay with graphing on a coordinate plane. Okay, so we're just going to apply our method here. So we're going to take all of our pre-image points and just change the sign of xy. So 180, again, when you first want to think about where it's going to end up. So starting at 180, or sorry, starting in quadrant 2, I'll leave my quadrants there. Remember, I'm going 1/4 of a turn and another 4th, so actually a half turn. So it should almost look like you're flipping across diagonally. So I should end up over here in 1/4, and it should, if I think about the way I'm rotating it, it should be oriented that way now. Okay, and that's actually the last method on this paper that we'll do. Okay, so let's go ahead and do that. So x is -5, -1, so x prime would just be +5, +1. Y prime would be +7, -6, and z prime would be +1, -2. So we literally are just switching the sign. Okay, when it says -x, -y, that means I'm negating those values, so changing the sign. Okay, so we can go ahead and graph our image. I'll give you a second to do that. Okay, so there's our image after we've rotated 180 degrees. Looks very similar to a reflection, so don't let that confuse you. Okay, and then our last method on this paper, I'm actually going to do another method that might not be perfect for the EOC for a computer-based test, but I'll show you some ways that you can, another 2 methods that you can use on an EOC. These are 3 not so great, sorry, I'm going to focus here. These are 3 really great methods, but sometimes not so great on the EOC. Since we don't have patty paper, we have to memorize our rules. And then this way it's really good if you have a paper test, but not so great for a computer. Okay, but again, this is good to just start visualizing. So we're going 270 counterclockwise, which means I'm going 90 degrees clockwise. I always like to move in 90 degrees because it's way less work than going all the way around. Okay, we do have a rule, but let's wait on that. So let's go ahead and graph our pre-image. I'll let you do that. Okay, so there's my pre-image. We want to think about where we're going again. So we're going 90 degrees clockwise. So to the left. I gotta think about that for a second. So we're going to rotate up, actually, back from quadrant 3 into quadrant 2. So we should end up in this positive y value up here. Still in the negative x's, but positive y's. So this method, we're actually going to turn our paper to use as a gauge for our new image. So there are multiple different methods. You can also, if none of these are making sense to you, you can always look at Khan Academy videos or YouTube. I even watch some YouTube videos in order to do these as well. So this is method 3, which is turning our paper. Or a screen, I guess, if you are doing an EOC. Okay, so we are literally taking this and turning it however many degrees we are going in whatever direction. So we are going to turn it 90 degrees. So it should be, it's facing side to side. I'm going to zoom out so you can see. It should end up facing up and down. So we're going to turn it a fourth of a way. So I'm going to turn my paper until this axis is turning to the right. And I'm going to zoom back in. Okay, and we've now created where we want our image to be, but now just switching my axes, and I can just read it the same way I would as if this were my x-axis and this were my y, and I can figure out my new points here. Okay, so I'm just going to write them off to this side. I use pink. Okay, so just if I were reading any normal graph, I'm going to plot these 3 points. So I'm at -1, +2 for r prime. That's -1, +2. I'm not going to worry about keeping on flipping back and forth right now. Let's see, q prime is 0, or 0, +1, 2, 3, 4, 5, 6. And p prime is -1, 2, 3, 4, 5, +8. -1, 2, 3, 4, 5, sorry. -5, +8. Okay, and then I'm going to turn my paper back around. And now I can go ahead and copy, oops, sorry. Technical difficulties. And now I can go ahead and copy in my, jeez, sorry guys. And now I can copy in my new image points. So P was -5, 8. Q prime was 0, 6. And R prime is -1, 2. And now I can just simply plot those on my normal graph, looking at it the normal way. So I'll give you a second. Okay, so just as we would normally read a graph, I just plotted my points. So this way kind of just does all the work for you. You're just rotating the actual paper and creating your new axis. Okay, so we can go ahead and zoom out and look and see what our rule would be if we were my people who like the rules. Okay, and we went from -8, -5 to now -5, 8. So I know my x and y have been switched. And then if I look at the one that has changed signs, it's 8, which went from a -8. So that would mean we switched the sign of x. So zooming out, those are 3 methods that we've done so far on rotations. Okay, so I'm going to do two other methods here. One using slope that we're going to do on number 2. And one just kind of doing a visual approach. Not really a method, just kind of a way that you can do it just by counting spaces. And I've kind of already started here, so sorry about that. So we're rotating 90 degrees clockwise, so we should be going from quarter 4 to quarter 3. We should be rotating clockwise that way. Always good to go ahead and think about that before we start. Okay, so this method is really just counting from your point of rotation, so in this case the origin, just kind of taking the motion of how we count and then just rotating that 90 degrees. So if I think about this point on the x-axis, I went away from my origin 2 spaces to get to it, and I'm on this origin, so if I'm on that x-axis, if I were to rotate that x-axis 90 degrees clockwise, I would spin around that origin and get to the y-axis. So I'm just spinning that motion 90 degrees. So here I went away to, now I'm going to move away to on my new axis there. So 90 degrees away from the x-axis we know is the y-axis because there's a 90-degree angle here. In case you didn't know that, those are perpendicular lines. Okay, so we're just, again, spinning that motion. So I went away to, to get to, that's I prime. We can just continue that pattern. You can also turn your page if it helps. This is now my new axis that I'm counting. So I went, let's do H. I went away to, and then over 1 is what I like to say. So I'm just spinning that motion to my new axis here. So I went away to and over 1 or down 1. And that's my H prime. Okay, let's go ahead and do G. I went away from the origin 1, 2, 3, 4, and then down 2. So I'm going to go away 1, 2, 3, 4, and down 2 to get to G prime. And the last one is on my y-axis, which means if I spin that 90 degrees, where will I end up? On the x-axis. So this is the farthest one down on the y-axis, so I'm going to go the farthest point down on my x-axis. And that's J prime. Okay, it doesn't look like much now, but let's go ahead and start connecting those points. So G and J should be connected. G and H are connected. H and I are connected, and that's not a point, that confused me for a second. And then J and I, so that long side over there. Okay, we see that it has been rotated 90 degrees. Sorry if I took that out of vision there for a second. So it's just spinning a motion, counting away from the origin and either up or down or over, however you want to think about it, and just spinning that to your new axis 90 degrees away. Okay, in our last method, I zoomed in here because I don't need to rotate the page anymore. We're rotating clockwise about the origin, and this one we're going to use slope. So if I think about what slope is, it is the rise over run of a line on a graph. So when I'm thinking about the slope in terms of parallel and perpendicular, I know that parallel slopes are exactly the same. They are the same slope, never intersect. And then I also know that perpendicular slopes create a 90-degree intersection. Just like our x and y axis, there's a 90-degree intersection there because they are perpendicular. I also know that perpendicular slopes are negative reciprocals. Okay, and that's kind of the rule that we're going to use here to help us. So we're really thinking about the line created with the origin and each point, and we're just like if it were a piece of string, we're going to keep our finger on the string at the origin, and we're rotating that 90 degrees. So we're finding the slope at which it creates a 90-degree angle. So we're finding our perpendicular slope. So slope is our rise over run. So that's all we're finding there. So I'm going to start with point L. So to do the rise over run, I'm going to count up from the origin. So 1, 2, 3, 4 is up from the origin. So M represents slope, and I'm putting the slope of L. You can't find a slope of a point, but I just mean that the line that's crossing through L. So what did I say? Up 4, and our run is positive 2. Now, unlike when we are normally finding slope, we don't want to change or simplify the slope here because it's telling me how many units to count. So I'm going to leave that alone, and I'm going to go ahead and find the negative reciprocal. So I know reciprocal means to flip it to 2 over 4, but here's the only tricky part that we need to know about slope, using slope, is where to put the negative. We usually just stick it out front, but it's actually attached to one of these numbers, and especially on a graph it's important. So we want to think about where my image is going to land. If I'm going clockwise, it means I'm going to the right, so it should end up from quadrant 1 and 2 to quadrant 1 and 4, so it should end up somewhere over here. So I want to think about that when I'm plotting my new point using the slope. So this just tells me where to find the slope, or where to find my point. So if I did this slope with a negative at the 2, let's see where that puts me. I would go down 2 and to the right 4, 1, 2, 3, 4, and that actually would be perfect. That's going to put me right where I want it. So that's point L prime. If I were to have switched it and made this a positive and made my 4 a negative, which is actually for counterclockwise rotations, let's see what that would do. I would go up 2 and to the left 4, 1, 2, 3, 4. That would put me up here in that opposite quadrant. So that would be actually moving counterclockwise. So when we're moving clockwise, we want that negative attached to the numerator there. Okay, that's really the only tricky part. The rest we can just continue on. So we can find the slope of, let's do M. I went 0 and then 2 as my rise over run. I know that's really just a slope of 0. Oh, sorry, that's not a slope of 0. 0 divided by anything is 0. So that's our horizontal line there. If I switch it, I'm still going to keep 0 on the bottom, even though I know that's technically undefined, which is on the vertical y-axis, but I can just use it as a set of numbers there. So negative 2, I'm going to zoom in a little more, negative 2 and 1, or negative 2 and 0, sorry. So negative 2 and 0 gives me point M prime. I should be using a different color, but sorry about that. So the slope going through point J is positive 2 over negative 1, 2, 3. So negative 2/3 is now positive 3/2. So I'm going to go up 1, 2, 3, and to the right 2. And that is my point J prime. Okay, when my original one is negative, before I do the negative reciprocal, we treat that just like we would anytime we do a negative reciprocal. So that doesn't matter which one it's attached to, we're just getting rid of that negative. Okay, the only other opposite of this I can do would be a negative 3 over a negative 2 in the case that we need it to be down here, but we don't. And my last one would be the slope of K, and that is positive 1, 2, 3, 4, 5, negative 3. And that's going to take us to a positive 3 over 5. So 1, 2, 3, 1, 2, 3, 4, 5, and that's K prime. And let's go ahead and connect. I'm going to use nice pink here. And hopefully we didn't make any mistakes. we look pretty good. Okay, we'll do an example down here, number 6, that would show the counterclockwise use of slope. Okay, so using slope, this is counterclockwise. Our other one was clockwise. We're going to find the slope of u, the slope going through v, and the slope going through t. So u, starting from the origin, let's think about where we should end. So rotation 90 degrees counterclockwise would go back up to quadrant 1. So the slope of u is negative 2 over positive 1, 2, 3, 4. The negative reciprocal of that is 4 over 2. 1, 2, 3, 4, 1, 2, and that's u prime. Okay, positive, positive I know is over here, so we're good to go with that. V is negative 1, 2, 3, 4, 5. 1, 2, 3. Let's go ahead and do t while we're at it. 4, 5. Sorry, positive 5 down there. Okay, we don't want to abbreviate that as 1 because that tells me how many units to count. We're going to leave that alone, so that becomes 5 over 5, and this one becomes 3 over 5. So 1, 2, 3, 1, 2, 3, 4, 5 gives me t prime. And 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 gives me v prime. And there's my new image. Okay, that wasn't a great example actually with counterclockwise because we didn't have to change any negatives there. Those were all positives. Okay, but just know when we're dealing with counterclockwise, the negative would go on the denominator. So for example, like 1 over negative 2. When we're moving counterclockwise, in some cases you'll have a negative on the bottom. When we are dealing with clockwise, that is counterclockwise, when we're dealing with clockwise, we have the negative on the numerator. So for example, 1 over 2. Okay, and those are all the methods, so all 5 methods. You have a homework that is due Friday the 16th. So you have a lot of time to practice there, but hopefully you have a method that works for you.